When we graph a quadratic, it's going to give us a parabola, and we can tell a lot about the parabola just by looking at the discriminant. And the discriminant is it's the part of the quadratic that's under this radical or the square root sign. We call that the discriminant. And it's another great shortcut for just kind of telling what are the properties of that quadratic going to be, without doing a whole lot of work. So here's a good example that I have. In this one, I'm asking, examine the discriminant of the quadratic and tell, is it going to give a non-real solution? And this is a great shortcut because we can kind of skip doing all these steps of solving the quadratic or graphing it just by looking at the discriminant. So on my first example here, this is not really in standard form. So let's first of all, let's move these things around. So 5x squared, I'm going to bring that down. The 7x, I need to subtract that over here. And then the 3, I'll bring that down also. And now it's in standard ABC form, so I can see the A is going to be 5, that leading coefficient. The B, the coefficient here is -7. And then the C is the constant, that's just the 3. Just like that, A, B, and C. And now I can plug these into the quadratic formula, right? So we're going to do negative B would be +7 plus or minus B squared, so -7 squared, minus 4AC, so I'm doing 4 times 5 times 3, and this is all over 2A, so 2 times 5. But really, I can tell, is this going to be real or non-real just by looking at the discriminant. So I can sort of ignore this, and just look at the radical, the square root. So let's go ahead and PEMDAS through this square root. And we'll ignore the rest. So -7 squared, that's going to be a +49. And I'm going to subtract from this 4 times 5 is 20. And then 20 times 3 is 60. So let's go ahead and subtract this. 49 minus 60. It's going to give me a -11. And really I can stop here. So already I can tell I can't square root a negative number. If you don't believe me, go ahead and try it. Take your calculator, type in -11, hit that square root button. It's going to give you an error because we can't really square root negative numbers. There's no real number that you can square to get a negative number, right? Because a negative always gives you a positive. So that's kind of the problem with this. I have a negative discriminant. And that means I'm going to have a non-real solution or non-real zeros. So this is a good shortcut. Again, you can just look at the discriminant. You can sort of skip the rest of the quadratic and just take a look at that. Let's try another one. So this one, again, this is not in standard form. We're still going to examine the discriminant, tell if it's going to be a non-real solution. So let's start off by rewriting this. This will be 4x squared. Bring down the 12x. And then this -9, I just want to add that over to the other side to give a +9. And that means that A, B, and C would be 4. B is this coefficient, 12. C is the constant, 9. And this time, let's kind of skip the part of the quadratic that we don't need, because all I really need is the discriminant. So let's write this radical. This is going to be B squared, so 12 squared, minus 4AC, so minus 4 times 9. And that's it. We're just going to skip the rest of the quadratic formula. Let's go ahead and PEMDAS this. So 12 squared is 144, and 4 times 4 is 16, times 9 is 144. All right, so you could probably tell what's going to happen here when we subtract these. 144 minus 144, you're just going to get 0. So this would actually have no roots if we graph this. Anyways, so the discriminant that we're getting here is 0. It's not a negative number. I can do the square root of 0. If I took my calculator, type in 0, hit the square root button, it's just going to give me 0. So this would only have one root, I guess one repeated root is what we call that, where the vertex would be right on the x-axis. So it would look something kind of like this. You have a vertex right here. Instead of having 2 intercepts, you're just having 1. But either way, this is too much information because the only point here is this is real. So this is not a negative number. 0 is not negative. If it's negative, it's going to give us non-real roots. But since it's not, then this is going to be real roots. Okay, one last example here. In this word problem, I'm saying a rocket is launched into the air from the top of a 64-foot tower. So that just means that our intercept here, where x is 0, we're starting off at 64, or the y is 64, and eventually it's going to land on the ground. The graph below shows the height y of the rocket from the ground after x seconds. So this is kind of plotting the trajectory of this rocket. The y is the height as we go through time here. And all I'm really asking is, for which interval is the rocket's height increasing? So when is the height increasing? So it looks like we're starting here at 0, right, from 64 feet. We're increasing as time goes on. Eventually we hit 192 feet and starting at 64, and then it starts to decrease after that, go back towards the ground. So the interval that this is increasing is really just from here up to here. So it kind of looks like we're starting at 0 and we're going to halfway between 2 and 3. So that's really the answer. We just have to write this in interval notation. So starting at 0, and going all the way up to 2.5. We can also write this using our normal notation. So another way I could write this is I could say x, it has to be greater than 0, greater than or equal to 0, but less than 2.5. All right, so these both say the same thing. These are just different notation.